Hello coders, welcome to my video. So in this video, we will try to catch the signals. Okay. So in the last video, what we have seen is we are sending the signal, an asynchronic signal to another process, and that process is not ready to accept this signal. So it ultimately, stops or flash. Okay, simple as that. But there lot of signals are there that can be handled by the another process so that the signal can be a inter-process communication, because right now whatever we have studied till now is we send a signal and the program got stopped. Okay, so when we make the program to accept or take that signal and then process it accordingly, when the real work of APC using signals is accomplished. Okay, so we have two types of signal. First are catchable signals, and second is uncatchable signals. So what are these? So in catchable signal we can get this interrupt, and we can do some action in that process uh, using a handler function when you receive this signal. So for example, these are few of the signals that can be handled. Okay, so in this we have sick child. So this is a ignore signal by default. For example, if your child process got killed, it will inform your parent using sick child that that process is been killed, and now it's the responsibility of the parent to do a certain action if it wants. If this signal is not been caught by the parent, it may be ignored by the parent, so there is no action on the parent. Okay, so this is also one type of signal that is that the process can ignore without stopping its operation. Okay, and there is approximately two, I think, is there, that is in the category of uncatchable signal, that is sig kill and sig stop. So these two cannot be stopped. We cannot handle this process. So let's start with a basic uh for a parent-child communication, and we will see how we can handle the signals from parent to child on child to parent. So for that, what I will do, I'll create a parent-child using a fork system call. For example, I have PID underscore T, PID is equal to fork. And now if PID is equal to 0, then it is a child process, and else it will be a parent process. So here in the parent, what I will do, I will just wait. Okay, and I'll take null here. Simple as that. So in here, what I will do, what we are doing, we are catching the signal in the child pixels. Okay, so what I will do here, I will take a API named signal. So in that we have two parameters. First is a signal name. So signal name, I will take sig int, and now I need a handler, so I'll just take handler here, and we have to define a handler using void handler, and here this function can pass signal number to this. Okay, and in here what I will do, I'll printf something. Okay, so that we can get when the signal got caught. So here what I have, I will have child receive signal percentage D from parent. Okay, that's it. Okay. So what we have done here, I registered a signal named SIGINT. Uh, when we get the signal to this child, I will be calling this handler. So I did some proper operation when we receive this signal. Okay. So what it will do? It will print the handler name, sorry, the signal name and this message. So I will print signal name as well here. Okay, and it will quit and it will continue doing the operation. Okay, so I register this signal, then I get a 5 second of sleep. And now the parent, what I need to do, I need to send that signal. Okay, so for that, what I will do, I will take sleep one. Okay, and after that, what I will do, I'll use a kill API. Okay, so kill will take PID of the process. Okay, and then it will send sig int. Okay, so what I will do, I'll put some printfs here so that we can understand properly. So here, send signal to child. Okay, and now child exited here. Okay. So what happens here? I register a signal and wait for 5 seconds. In the meanwhile, the parent, after 1 second of sleep, it will be sending this signal. I am closing this sending signal to, and now I will see what all the prints will be coming. So I will take GCC signal and here hyphen o sig. Okay. Oh, I got lot of errors. So I think we missed the header files. So here I will take signal. Okay. Uh, now I have few warnings. And for that, what I will do, I'll take Unisted for fork and other calls. Uni std.h and I close it. I think this will be done if I use sig. Now observe. Sending signal to child. This is the first message after 1 second from the parent, and child receives signal 2 from parent. This is the handler print and child exited. Okay, so the thing here is this signal is received by the child, and after that it got exited after 5 seconds. So proper execution of this is there. Okay, so this is the example of the quotable signals. We can catch these signals. So here we are catching the signal that is sent by the parent to the child. Okay, and we are processing that interrupt using this handler. So whatever operation we put it here, that will be executed with that signal or interrupt. So this is how Linux manage signals. if we have signal here and we register the signal handler that is unquotable, so we will put signal here, and now if I compile it and run it, you will see you will only get send signal to child. You will not get this signal is caught by the parent. This is killed by default. Also, if I try to ignore this signal in spite of using a handler, and then I try to save it, and I will compile it and run it, then see what happens. It's again is not handled, it's not been ignored. We are not getting child inserted from here. Okay, and that's why it's not been handled. So in spite of this, if I again use sigint, and here also I need to make sigint, and I just ignore this signal. So again, if I compile it and then if I do this, so sending signal to child for 5 seconds, child will be exited. So that signal is being ignored, and this is the behavior in which we can alter the default behavior of the signal as it is mentioned in the kernel, and we make it to ignore or having no operation on this uh, function, okay, or this process. So this is all about handling the basic signals. So let's see in the next video. Thanks.